Hi, this is Mrs. Carnes, and this is the second video on properties of parallel lines. In this video, we're going to actually look at some examples of some problems that you might come across. We're still going to be looking, though, at that same picture of a transversal intersecting parallel lines. So all the things that we're going to talk about are going to be defined all 8 angle measures when you have that picture of a transversal that intersects 2 parallel lines. We must know one of the 8 angle measures, and if we know one of them, we can find all of the 8 angles in that picture. Let's take a look at an example. So in this example, it says, find the measure of all 8 angles. And if the measure of angle 8 is 75 degrees, then find all the other angle measures. So the very first thing that we're going to look at is we're going to say, okay, we do have a transversal here, and it is intersecting parallel lines. That's very important because remember, in the last video we talked about all that postulate and all those theorems that said that they were only congruent and supplementary if those lines are parallel. So since we know that those lines are parallel, we know that all of those are going to hold. So let's go ahead and label our picture here. We first of all know that angle 8 is going to be 75 degrees. So I'm going to write that here so that I understand that's the one angle that I am confident that I know. Now, if we know that angle 8 is 75 degrees, we also know that angle 3 is 75 degrees. And the reason that we know that is because angle 8 and angle 3 are corresponding angles, and since the lines are parallel, we know that corresponding angles are congruent because of the corresponding angle postulate. So we know that angle 3 is 75 degrees, and now angle 8 is 75 degrees. Now, we could also say that angle 6 is 75 degrees. Now, we can actually say this angle 6 is 75 degrees in a couple different ways. First of all, we know that angle 3 and angle 6 are alternate interior angles, and since the lines are parallel, we know that alternate interior angles are congruent. We know that because of the alternate interior angle theorem. We also, though, would have known that angle 6 was 75 degrees if you remember that angle 8 and angle 6 are vertical angles, and we know that vertical angles are congruent. So we would be able to say that. Similarly, we'd be able to say that angle 1 was 75 degrees, and we could say that because of corresponding angles with angle 6, or we could say that because of vertical angles with angle 3. So we already have 4 of the 8 angles. Now, we could take a look at angle 1 we know is 75 degrees. Angle 1, let's look at angle 7. Angle 1 and angle 7 are same side exterior angles. And by the same side exterior angle theorem, we know that they are supplementary. And so if we wanted to find the measure of angle 7, we would take 180 degrees, because we know they're supplementary. We would subtract off the 75 that we already know, and we would be left with 105 degrees. And so angle 7 would be 105 degrees. Now we could find angle 4 because it's corresponding to angle 7, so it's congruent. It'll also be 105 degrees. We could then say angle 2 is also 105 degrees because it's vertical to angle 4. And angle 5 can be found to be 105 degrees also because it's either vertical to angle 7 or because it's corresponding to angle 2, or even because it's same side interior to angle 3. And we know again by the same side interior angle theorem that those two angles must be supplementary since the lines are already parallel. So because we knew one angle measure and the lines were parallel, we could find all the 8 angles together. Let's take a look at another example that'll be a little bit different. Now in this picture, they want us also to find all 8 of the angle measures, but they don't really give us a whole lot of information. However, they do tell me this statement here that line AB is parallel to line CD, and I can also see that based off of these symbols here. So I do know that we have a transversal that is cutting parallel lines, so that postulate and all those theorems that we talked about in the last video, we know that those all hold for this picture also. So what I'm going to look at is I'm going to look at the two angles that they've given me, which is this angle x plus 30 degrees, and this angle 2x plus 20 degrees. When I look at these two angles, I know that those are corresponding angles, and since the lines are parallel, we know that corresponding angles are going to be congruent. So I can come up with a statement that says x plus 30 degrees must be equal to 2x plus 20 degrees. And if I can solve this for x, then we can find those angles. So I'm going to subtract 20 from both sides. I'll get x plus 10 is equal to 2x. I'm going to subtract my x from both sides. I'm just solving a basic equation. And I'm going to get the final answer for x is equal to 10. And so now that doesn't give me an angle measure, that just tells me what x is. So now we can plug that x back in. If we plug in 10 for this x right here, then we know that this angle measure is going to be 40. Now, we also know that this angle measure will be 40 because they're corresponding, they were supposed to be congruent. But just to check to make sure, 2 times 10 is 20, plus another 20 is 40. So we now know that these two angle measures are going to be 40 degrees. Now we can continue on and we could use alternate interior angles and say this one is also going to be 40, and corresponding angles or vertical angles would prove this one to be 40. Now if we wanted to find the other four angles, we know that they're going to be supplementary, and so we would take our 180 degrees because that's supplementary. We would subtract off the angle we already know, which is 40, and we would be left with 140 degrees. So the other angles are all going to be 140 degrees because they're all supplementary to something that we have on our picture. And once we have all of those labeled, we now know the measure of all 8 angles. So notice how this one was really similar to the last picture, except we had to find that x value first, so you had an equation that you had to solve. Let's take a look at one more example. Now in this example, this is to find angle measures using shapes. Now this might not look like the pictures that we've been talking about of a transversal cutting two parallel lines, but we are going to see that it's very similar, and we can get that picture out of this. This statement tells us if the measure of angle A is 130 degrees, then find the measure of angle B. So I can go ahead and I can label my angle A is 130 degrees. I know that that angle is 130. Now, I see parallel lines here. These symbols tell me that the top and bottom of my trapezoid are parallel. If I just extend these lines out just a little, as if I was imagining them going out and extending out a little bit further, I then can also extend this line out a little bit further in both directions. And now I can see that I have that picture that we've been talking about. I have a transversal that is cutting two parallel lines. And here's the 8 angles that are formed. Now we're only interested in angle A, which we already know to be 130, and angle B. So we have to decide what is the relationship between angle A and angle B in our transversal cutting our two parallel lines. And we know that those two angles are same side interior angles. And since the lines are parallel, using the same side interior angle theorem, we know that angle A and angle B will be supplementary. So we can say 180, we can subtract off angle A, which is 130, and we would be left with 50 degrees. So the measure of angle B is going to be 50 degrees. So you can see that there are many examples of parallel lines being cut by a transversal where you can find lots of different angle measures if you have one piece of information. So don't get discouraged if it doesn't look exactly like a transversal cutting two parallel lines. Usually you can extend the lines out to make that picture appear.